Namaste children, I am Ramchandra Bhatt, science teacher at Government High School, Batrayanpura. I am welcoming you to the Samveda e-learning program. Today, let us study a very important chapter. Already you know, this is the second session of the chapter, Is Matter Around Us Pure? What are you seeing here? So beautiful colors, right? Are they pure? I know. Now you know that these are the mixture of several pure substances, right? Then let us continue this chapter. Is matter around us is pure or not, right? Now the important learning points of this session, that is evaporation, the next one centrifugation, the next one separation of two immiscible liquids, then you have sublimation. After that, not only this much, this session covers chromatography, distillation and fractional distillation also. The next slide, separating the components of a mixture. Now let us understand what is the importance of separation of various components of the mixture. The heterogeneous mixture can be separated by various means, that is the physical methods like hand picking, sieving, then filtration. Sometimes we have to go for special techniques like chromatography, filtration, distillation, decantation and so many other methods. Hence, now let us understand what are the various methods used to separate various substances. This depends on what type of mixture it is, what is the size of the particles, how the solute and solvent, how they were mixed, whether they are miscible, whether they are immiscible. All these factors decide what is the type of method you have to adopt or use to separate the components from the mixture. Now here is how can you obtain a colored component, that is the dye, from blue black ink, or how will you separate the salt from water? What are you seeing here? This is the method of separation of colors from the ink. First you have to vaporize the water, that is the solvent, where here solvent is volatile, solute is non-volatile. Then you are going for this method. Here I am taking the colored dye, that is the ink, in a watch glass, then heating over a water bath. Then gradually water vaporizes, leaving behind the solid solute. That is the method called filtration. Now we can separate the volatile component from its non-volatile solute by the method of evaporation. This is the evaporation method, right? What is this? Now let us separate salt from water. Here I am adding small amount of salt solution in a frying pan. Now I am boiling. Observe carefully what happens. As the heating continued, water vapors escapes, leaving behind solute salt here. Observe, the mixture started to boil. Now you are observing what? This is the salt. Now we evaporated the water, now salt is left behind. Thus we can separate salt and water from the salt solution. So this is familiar method for you. This is the same method is used to separate salt from ocean water. I hope you understood this one. Now, how can we separate cream from the milk? That is also very simple. This is the very simple method. In your home, you are using this method. Sometimes solid particles in the liquid are very small so that they can pass through the filter paper. Then such particles cannot be separated by filtration technique. Then you have to go for a separate method, that is centrifugation. Here the density difference also observed. Now let us see how to separate the cream from the milk. The principle of centrifugation is that denser particles are forced to the bottom and lighter particles stay at the top when you spin the mixture rapidly. This is the centrifuge used in industries or laboratories wherever it required. Here is the practical. Now let us see how the churning of the milk is done at home. Observe, the cream is getting separated now because it is lighter. This is very useful technique, widely used in where? You are seeing this is the scene of laboratory. In the laboratory, to separate many components from the blood and also from the urine, this is used, right? Yes. In the blood test and urine test, we are adopting centrifugation. Application of the centrifugation is seen in our home. What is this? Yes, you know, this is washing machine. Then what is done? We are using washing machine to squeeze out the water from the cloth. So it is very familiar to you. You can easily remember. Not only this much, it is used in dairies and also at home to separate, that is the butter from the cream. How can we separate a mixture of two immiscible liquids? Immiscible, miscible. When they are mixing evenly, that is miscible. If not, they are immiscible. Example, kerosene and water, oil and water. Here the difference in the density is observed. Hence, lighter floats over the denser one. The principle of this technique is, here two immiscible liquids separate out in layers depends on their densities. This is the separating funnel. Here you are taking kerosene oil and water. You know clearly they do not mix with each other. Hence, you have to go for separating funnel. When you on the stopcock, first heavier water comes down, and when it comes to the at the interface of kerosene and water, you will stop the stopcock. Then in the separating funnel you will have what? Kerosene, and heavier water comes down. It sinks, right? What is this? So beautiful, right? This is once again the same process, separating funnel. To distinguish two different colored liquids, I used some colors. Observe them carefully. What is happening? Here heavier, the blue solution coming down, right? Like this we can easily separate. To separate the mixture of oil and water which have different densities, then we are going for this method. This is separating funnel. You can make your own separating funnel by using trashes. Now see, what is this? This is one more application of this method. Here the difference in the density used to separate the things. Here in the extraction of iron, the lighter slag is floating over molten iron. Molten iron is tapped out here at the bottom, right? Like this we are separating many mixtures. It has wide application in various industries. How can we separate a mixture of salt and camphor? Sublimation is the process used to separate a mixture which contains a sublimable volatile component, another one non-volatile, non-sublimable substance. One is sublimable and one is non-sublimable. Then you can easily separate. This is called as sublimation. Example, the mixture of salt and camphor you can separate with this method. Here is the diagram, you have to practice this one, very simple one. The dry ice and sublimation. Observe here. What is this? In a bucket, I have taken some dry ice, I am adding hot water to that. What are you observing? See here, the ocean of carbon dioxide. So, dry ice is an example for sublimable substance. Now, let us have a method of separation of salt and camphor. This is the activity I am showing you. Observe this activity. What are you seeing? This is the mixture of camphor and salt. So, I am taking this mixture in a frying pan. Let me heat and invert a coconut shell. Observe what happens. Now I am heating. Children, observe carefully. You should not do this one at your home without your parents' help, because camphor is, yes, it is highly combustible substance, catches the fire. Observe, now I am heating the mixture. After some time you will see. Now observe, what is this? This is the camphor. So, you came to know how to separate the mixture of salt and camphor. This is the camphor found attached to coconut shell, right? This is similar to that process what I shown in the figure, right? Now, here is the separation technique chromatography, where we are separating several colors from a color mixture, right? Now, what you have to do? First, you have to take a filter paper, strip of filter paper, on which you are seeing here a spot of ink which consists of several colors. You can use your sketch pens. You can mark several colors on this baseline. Then dip this one in water so that the ink spot should be above the water level. Observe what happens. You will see the magic of separation of colors here. This is another kind of chromatography. In this process, the separation of components of the mixture from a dye takes place, hence it is called as chromatography. Chroma means color, hence the name. Earlier, this method is used to separate the colors. Now, we are using paper chromatography, where we are using water as a solvent. As the water rises in the column, it dissolves the color, depends on the speed. Observe here. Observe this one carefully. So, the pigment contains several colors, you can separate like this. So beautiful, right? This is the magic. Here, the dye is a mixture of two or more colors. The colored component that is more soluble in water rises faster, and in this way the colors get separated. That is the method. Now, you can make your own chalk chromatogram. What you have to do? You have to take a chalk piece. Mark a baseline just above 1 centimeter from the base. Then make the spots by using your sketch pens. Let us take red, blue, green. After making the spot, what you have to do? Take small amount of water in a watch glass. Keep the chalk piece in the water so that the water level should be below the baseline. Now gradually water rises, along with that you will see separation of colors. Already you know what colors you mixed, so you will see all the three colors. So beautiful, right? So you can learn chromatography at your home. Now let us see what are the important applications of this chromatography. Chromatography is widely used to separate the colors from the dye, pigment from the natural colors, drugs from the blood, and also you can identify adulteration in the chemicals. So you can test whether the given chemical is pure or not. Like this, we have a lot of applications of this chromatography in the industries. Here, how can we separate a mixture of two miscible liquids like alcohol and water, acetone and alcohol, or any organic solvents? Here we are having the mixture of acetone and water. Here you are seeing in a round bottom flask or distillation flask, we are taking the mixture of acetone and water. Water boils at 100 degrees Celsius, while acetone boils at 56 degrees Celsius. The thermometer shows the temperature at which the acetone boils. First, from the mixture, acetone vapors escapes. As they passes through the condenser cools. Water is flowing through the water jacket, keeps these acetone vapors and condenses, hence the name condenser. Now acetone is collected in another vessel, while water is left in the round bottom flask only. This is the method of separation of two miscible which can mix evenly, right. Now here you are having a video of distillation. Here we are having a distilling flask in which methanol and methylene blue are taken. Here methylene blue is non-volatile component, while methanol is volatile component, whose boiling point is roughly around 65 degrees Celsius. When you heat the content, the vapors passes through condenser, then they were gradually cooled and converted into liquid, then they were collected at collecting vessel. You are observing here water cooling the mixture and vapors are condensed into liquid and collected in the another vessel, right. This is distilled methanol. Now the distillation is used to separate the component of a mixture containing two miscible liquids that boil without decomposition. You should remember, they should boil without decomposition, and also they should have sufficient difference in their boiling points, then only we are able to use distillation. Already you saw how the methanol separated from methylene blue, similarly acetone from water in the diagram. What are you seeing? So beautiful, right? This is once again related to distillation only, but some different name we are using. This is a fractionating column. Here we are using fractional distillation to separate the components of petroleum. The petroleum consists of petrol, diesel, kerosene, naphtha, etc. Because of the difference in their boiling points, we can separate them very easily when they pass through this fractionating column. If these mixtures whose boiling point at least less than 25 Kelvin or 25 degrees Celsius, then fractional distillation process is used. Example, separation of different fractions from the petroleum. Similarly, separation of different gases from the air, this is also very important. Here the apparatus which is similar to that of simple distillation, except that fractionating column is fitted in between the distillation flask and the condenser. Just now you saw the picture of this fractionating column which is fitted in the distillation flask, right. Here we are using a glass beads as another kind of fractionating column. There are different types of columns are there. Here what we are using is a glass bead containing fractionating column. So here distillation flask is connected to a fractionating column, and then it is connected to a condenser at the bottom. At another terminal, another end of condenser is in contact with this collecting vessel, and thermometer is used to check what is the boiling point or what is the temperature of the vapors. Thus we are separating many fractions from a mixture. This is the quiz time. Let us test what we learned till now. Are you ready? Yes. Let us start the quiz. In the quiz time, the first question is, camphor is separated from copper sulphate by what method? Evaporation, chromatography, sublimation and distillation. What is your answer? Let us test. The answer is sublimation, because camphor is sublimable while copper sulphate is not a sublimable substance. Second question, identify the process. What is this? The method of separation shown here is chromatography, then evaporation, separating funnel and centrifugation. What is the answer? The answer is right, separating funnel. It is not chromatography. Don't get confused with colored components which are taken in the vessel, right. Next question. Next quiz question is the method used in washing machines to squeeze out the water from wet cloths. That is evaporation, filtration, centrifugation and chromatography. What is the answer? The answer is centrifugation, right. Next quiz. Next question. Volatile solvent from its non-volatile solute can be separated by the method called, what is the method? Evaporation, filtration, centrifugation, finally chromatography. What is the answer? Yes. Let us check. The right answer is evaporation, right. Very good. Now we came to last part of the class, that is the home assignment. Here are the questions. What are the applications of centrifugation? Then what are the various criteria behind the selection of method for the separation of components from the mixture. Already I told. I hope you remember all these things. Please note down these questions, try to answer, and also you can discuss with your friends and also send to your teacher. You can show these things to your teacher so that you will understand the concept in depth, right? Okay, a student wanted to check up the purity of a chemical given to him. Suggest a method with the suitable reason. You have to tell why you are suggesting that particular method. What is the rationale behind that? Now, next question. The next question is, draw a neat label diagram of sublimation and explain the role of funnel in the process. You have to draw the diagram as well as you to explain what is the role of funnel in that one, right? Next one, how is fractional distillation is different from normal simple distillation? How is fractional distillation is different from simple distillation? These are the 5 important questions related to this session. I hope till now you enjoyed many concepts taught through various activities and experiments. So beautiful activities, a few you can do at home, right? So let us meet in the last session in the next class. So till then, namaste, bye bye.